Hello students, the continuation of thermal properties of matter. In this session, we are going to learn about the modes of transfer of heat. The modes of transfer of heat through conduction, convection and radiation. Then the thermal conductivity. Let us see children. Yes students, modes of transfer of heat. We can transfer the heat through three different ways. That is conduction, convection and radiation. Conduction, actually this is the process of heat which is transmitted from one part of the body to another part at low temperature through the molecular collision. This is actually without any disturbances of any actual flow of matter. So actually solids are heated through this conduction actually children. When one end of the metal rod which is heated, then the molecules are getting vibrated and it is getting transferred from one end to another. If suppose you have taken any metal rod while you are heating it, you are heating here, what will happen? The molecules are transferring the heat, right? It is transferring from one molecule to another. That likewise it will be the heat is transferred. So here it is in solids it is very possible. Now the next one is convection. The convection is the process of heat is transmitted through a substance from one point to another due to the body, that is bodily it is motion of the heated particle. That we can say that it is usually happening in fluids. Fluids which is heated, that get heated through convection, when a fluid is heated up means it will get actually expands. The density will get decreases and it is rises upward. The colder fluid moves downward. So this we can call it as a convection current. In that way, the convection current, maybe the molecules, water vapor. So water, you have taken some fluid in that way. What will happen? Whilst it is getting the molecules which are getting heated, it will be get transferred. This we can call it as air currents, right? So this is usually happening in the fluids. Now the next one is, we are seeing that is radiation. The radiation which means the heat which is transmitted from one place to another without any changes, without heating the intervening medium. So this we can say heat from the sun that reaches the earth. So because of this process of radiation only, right? So it involves the transfer of heat without any help of the material of the medium. We need not any material to transfer this through radiation, right? So next one is thermal conductivity. See the diagram students. See, you are seeing a block of material of cross-section area is A we have taken and the thickness X. Suppose its opposite phases are at temperatures T1 and T2. See, the hot phase that we have taken as T1 and the cold phase that we have taken as T2. With the T1 is greater than T2. So we have taken that T1 which is greater than T2. Now the amount of heat that is Q flow from hot to cold phase during the steady state temperature, that we can say the Q which is directly proportional to the temperature and the area. First you can say take the area, right? The cross-sectional area which is directly proportional to the amount of heat which is flowing through that phases. And the same way the Q which is directly proportional to the difference between the temperature T1 and T2, right? So this is, see that temperature because of we have taken T1 as a hot phase and T2 as a cold phase, right? and also it is directly proportional to the time. We have taken the time. Yes, Q is inversely proportional to the distance, right? So the distance which we have taken as here x, so that the thickness or the distance of the block. So this is also depends on the nature of the material of the block. So here we can write Q, which is directly proportional to A T1 minus T2 into T whole divided by x, or else we can write Q, which is equal to Ka T1 minus T2 into T whole divided by x. This K, we can say that the proportionality constant of the thermal conductivity. So the coefficient of thermal conductivity K, it is depends on the nature of the material, right? Next one is convection. As we discussed about this statement, that is heat which flows from the region of the higher temperature to the region of the lower temperature by the actual movement of the material of the particles. See the diagram, students. The fluids are actually heated mainly by the process of convection, in which the buoyancy and the gravity which plays here the important role. When a fluid is heated from below, the hard portion which are at the bottom will get expand and become less dense. So at the bottom, it is getting very less dense. So the material, that is the molecules are getting very less. And because of this buoyancy, this lighter portion or raises up. See the arrowed part, it is getting raises up. The denser colder fluid which takes it by moving downwards. The convectional current is set up in the fluid. The actual movement of the liquid that can be seen by coloring the liquid with the potassium permanganate crystal at the bottom. You can easily see in the laboratories, right? So the conventional current. The conventional current, which we can say that fluid particle in contact with the source of heat which become harder, expand and become lesser dense. See this you must know. The fluid particle in contact with the source of heat, then at time it will get, the molecule will get hotter so that it is getting expand and it is less dense so that it raises up. Okay. So this process we can call it as a convectional current. The phenomenon which are based on the thermal convection. One is we are seeing here in the regulating the temperature of human body. See, in the human body, the heart actually acts as the pump that circulates the blood through the different part of the body. It is transferring the heat by the forced convection. This is only maintaining the remarkable constant temperature in our body actually. Next one is you are seeing that land and the sea breeze. Land and sea breeze, as we have studied from the lower classes, as you know. So these are actually local convectional current. The specific heat of water is higher than the soil. So the land and hence air above is heated faster in summer during the daytime. Then air above the sea. So the air above land expands and rises its place, is taken up by the colder air from the sea. Right. So this we are saying that the land breeze and the sea breeze, the circulation of the air current, land breeze and the sea breeze you have studied. Right. So this is convection and the convectional current. Yes, students. So far we have learnt about the modes of transfer of heat through conduction, convection and the radiation, and thermal conductivity, coefficient of thermal conductivity. You may have understood. Thank you, students.